What's up guys, my name is Liadoshen. Welcome to my data structure series. Today I'm gonna talk about the operations of signaling list. I have already discussed about what is signaling list. If you haven't seen that video, please check out the link in the description below. See that video, then come to this. So I wanna tell you a short description about signaling list. You can think signaling list as a train. So the engine part of the train is the head, other parts of the train are the nodes. So they are linked with each other one by one, right? So the engine part of the train is pointing to the first part of the train. In the same way, the head of the linked list is pointing to the first node, right? Let's see the operations of signaling list now. There are actually three types of operations we can do in signaling list. First of all, we can do insertion, insert a new node or value in defined position. We can insert a node at beginning, we can insert a node at the end, we can insert a node at an internal position between any two nodes. Right? Deletion, in the same way of insertion, we can delete a node or value from a certain position of a single list. We can delete a node from the beginning of a linked list. We can delete a node from the end of a single linked list. We can delete a node from an internal position of a single list. So then we can traverse the single linked list. If we have to print all the values of the single list, we have to traverse the whole linked list, right? And also, if we want to get a value of a certain position, we have to traverse, right? So then look at some insertion operation. We can insert a new node in three ways. First of all, prepend a new node. So we can add a node at the beginning. This is called prepend, right? So we have a linked list of node A, B, and C. We want to add a new node D at the beginning, right? So what we have to do? First of all, we have to give the address of the first node, which is A, into the next pointer of D, right? Then we have to change the direction of head, right? We have to give the address of the new node D into the head. So in this way, we can prepend new node in a linked list. Then append a new node. We can add a new node at the end of a linked list. So we want to add the new node D at the end of the single list. So what we have to do? Firstly, we have to give the address of the new node D into the next pointer of C, okay. Then this null will be removed from the next pointer of C, right? So then we have to give this null into the next pointer of D, okay. Then insert a new node. Suppose we want to insert a new node D between the position of B and C, okay. Firstly, we have to give the address of the next node C into the next pointer of D. Then we have to give the address of the new node D into the next pointer of B, okay. Because when we will give the address of the next node C into the next pointer of D, we will find the address into the next pointer of B, right? So we link the node B and D firstly. We will lose the address of node C, right? So firstly we have to link C and D, okay. Then we have to link B and D, okay. Cool. Then the traversal operation. If we need to print the whole linked list or find the value of a certain index, then we have to traverse the linked list, right? Then we can print the whole linked list by traversing the linked list. So to traverse the linked list, we have to start from a pointer which is called head. Then from this pointer, we have to go through the next pointer until it gets null. When we will get null, we will reach the end of the linked list, right? So similarly, to find the value of a certain index, we have to go through the linked list in the same way. In the case we reach the index, we extract the value of it and break through the loop. Okay, so let's jump into the code now. Okay, this is the CPP file. We will create a single linked list. I have already done the basic stuff. So in the basic stuff, we have a single linked list class. We have to create this class. We will see this later. First of all, to create a single linked list, we have to create node first, right? So we will create class of node. Okay, you can create this by structure. These two are actually same. The difference is the members of the structure is by default public and the members of the class is by default private, right? This is the only difference. The others are same. Class is not allowed in C actually, right? So this can be done in only C++. So first of all, we want to make all the members public. Then in node, what we have a data field and the next pointer, right? Then a next pointer, which then we will create a singly linked list class. Will make all public. Okay, first of all, in the single linked list class we have nodes, right? So to traverse the single linked list, we will need a head pointer, right? So we have to first make this not pointer. Then we will make this head pointer null when we will create this data, right? When we will create a data of single type single list, we will make the head null automatically. So how can we do that? We can do that by simple constructor. So this is the constructor. Constructor is actually a function which is named in the same of class name, right? So this is called automatically actually when we declare this. When we declare this function will be called automatically. So inside the functions, what we will do, we'll do automatically. We will do the head null. Okay. This will be created automatically. Then let's see what we have done in the basic stuff. We have done a simple loop, do while loop. Inside the loop, we have print out some commands. Firstly, press 1 to insert a new node at beginning, right? We will get options to press. So these are the operations we will do according to the pressing of options. If the user press 2, we will insert a new node at the end. If the user press 3, we will insert a new node at an internal position. If the user press 4, we will traverse the linked list and print all. Okay, let's okay, we have to create a new node, right? So firstly, to create a new node, we have to get a value from the user, right? What they want to make a new node. So let's print out sub command. So let's get the value element. Okay, then we have to create a new node. So then we have to give the value into the data of new node, right? So this is the element. Okay, then what I have to do to insert the node in at the beginning. Suppose we have some nodes. These are the nodes. We want to insert a node at the beginning. Okay, in that position. So what you have to do? Firstly, we have to give the address of the first node into the new node, right? This way. Or we will find this address. We will find it into the head, right? Because the head is pointing to this. Okay, head is pointing to this node, so we will find the address of the first node into the head. So from head we will give the address into the next pointer of new node. So then we will change the direction of it, we will give the address of the new node into the head. Okay, in this way. But to do this, firstly we have to check the linked list is empty or not, right? If the linked list is empty, so there are no nodes, right? So how can we check that? So when the linked list is empty, the linked list is empty when the head is null actually, right? Because suppose we created this data of single linked list, so this automatically null the head. So if we don't do any operation, the head will be automatically null. Okay, so if the head is null, then the single linked list is empty. So let's check this. So what we will do then we will give the address of the new node into the head simply, right? So this is actually new node, this is the address of the node actually, because we have created the pointer of node, so this is the address, right? So then we have to give the next pointer of the new node null, right? Because this is the last node, right? So then we will simply return. But if the single list is not empty, then we will do these operations, right? Then we will do these operations. Firstly we will give the address of the first node from head into the next pointer of the new node, then we will change the direction of it. Okay, so let's do this. Firstly give the address of the first node into the next pointer of the new node, this is in the head. Okay, give the address of the new node into the head. Okay, same. That is all insert beginning function. Okay, then so first of all we have to get the value of the new node, right? So for that we have to print out a command, then we will get then we will create the new node, then we will give the value into the new node to the data of new node, this is element. Okay, then what we have to do to insert a new node at the end, firstly we have to check the linked list is empty or not, to check head is null or not. For that, so if the single linked list is empty, simply we have to give the new node into the head, then we have to give a null into the next pointer of the new node, because it is the last node, right? Then we will simply return. So but if the single linked list is not empty, then we have some nodes, right? Then what we will do, suppose we have these two nodes, so we want to insert a node at the end, this is actually null, right? So firstly what we have to do, we have to find the last node, right? So to find the last node we have to traverse the linked list. So when we will find the last node, when we will find the next pointer of a node is null, then we will find the last node, right? Because the next pointer of the last node is null. So in this way we can find this. So to find this we will we will go through a loop. So let's find this. Firstly, we will create a temp. This will go through till we find the next pointer of temp is null. So we will do simply temp equals to temp next. We'll do the next node simply. We'll go to the next node. Then suppose then in this stage we have reached the last node, right? Then what we have to do, we have found this last node, so we have to give the address of the new node into the next pointer of the last node, right? So then we have to give null in the next pointer of the last node, sorry, new node. So firstly we have to give the address of the new node into the temporary pointer, which is actually the last node of the single request. So then temp of next will be new node, right? Then we will give null into the next pointer of the new node. Next pointer of the new node will be null. Okay, this is all. Then we will do, so again, for this insert internal function we can do this in two ways. So first of all, suppose these are the nodes in single linked list. Okay, so we want to insert a new node, suppose between these two nodes. Okay, so we can do this in two ways. We can do this by giving a node after a node, or we can do this giving a node before a node, right? We'll do the first today. We'll insert a new node after a node. So you can insert a new node before a node. It will be homework for you. So to insert a new node after a node, we have to get the node firstly, this node, right? After which we have to insert a new node, right? We will get it from user. So firstly, we will print out a command. Then we will get the value. Then now we have the value after which we will insert a new node, right? Then we have to reach this value, right? We have to reach this node. So for this we will create it. So we will go through a loop until temp is null, right? If the temp is null, then we will reach the end of the linked list. Okay, we will go simply temp equals to temp of next. We will go to the next node by one. In this position, temp is null. So if the temp is null in this position, then we can show that uh, the node is not found, right? So we can command out this. So firstly we have to check if temp is not null or not. If temp is null, then we have to print out that invalid. Then we will simply return. If the temp is not null, then we have found the new node. So what we will do, firstly we have this node, right? We have the address of this node. So firstly we have to link this node with this node, right? We have to give the address of this node into the next pointer of this node, right? So where we will find this, we will find this into the next pointer of this node, right? Because it is linked in the next pointer of this node, we have the address of this node. Okay, so we will give the address into the new node, next pointer of new node. So then we will give the address of the new node into the next pointer of this node. Okay, this is all. So firstly we have to get the node, right, which we want to insert actually. So for that we have to print out a command. We'll take it. Okay, we will create a new node. Okay, we will give the value to the data of new node. Then what we will do, firstly we have to give the address of the new node, which is into the next pointer of the current node we have found. So we will give this address into the next pointer of the new node, right? So we have to give this into the next pointer of new node. What we will give, we will give the next pointer of 10, right? Then what we will do, we will give the address of the new node into this node, right, into the next pointer of this node. So temp of next will be new node. Okay, this is all done. Then we have only a function which is traverse. Traverse will print the values. So to do this, first we will make it, then go through a loop until we found null. Simply print the values, simply print the data of temp. Give it, then go to the next node. Right, all that it is. So I will give a inline in this position. All are done. Sorry, inside the insert int function, we have left it as it equals null, but it will be not equals null, right? If we get the next value is null, next pointer is null, we will break the loop, right? So it will be not equals to. Let's check how many errors. Okay, okay, there is an error, 932. Okay, this is will be actually next, right? Let's run this again. Okay, another error. Okay, let's check this in line 28. Sorry, it will be new node. Let's run this again. Okay, now all are fine. Suppose we want to insert some values in the linked list. Suppose we want 2, then 5, then 7, then 4. We want these 4 values in the linked list. We want to insert in some way that these values will be in this position. So firstly, suppose we want to insert at beginning. So we want to insert 2 at the beginning. The elements we want to insert at the beginning. Okay, let's check the values. Suppose we want to traverse there and print. To traverse we have to press 4, right? Okay, we have a value, this is 2. Suppose we want to insert another value at the end, so we have to press 2. Enter the elements we want to insert at the end. So suppose we want to insert 4. Okay, now let's check this again. Press 4. Okay, we have 2 for now. So suppose we want to insert at an internal position, right? So we have to press 3 now. So enter the value of the node after which we want to insert a new node. So suppose we want to insert a value after 2, suppose. So we have to insert 2. Okay, then invalid node, there's some error. Okay, there is errors that if we have found the node, we have to break this loop, right? So if we have found the value that is new, the data of new node, sorry, the data of temp, data of temp is equals this value, then we have to break, right? Okay, we'll delete this and let's run this again. Okay, let's insert at the beginning. Let's insert 2. Okay, let's check it. Okay, 2. And then insert at the end. Press 2. Enter the elements you want to insert at the end. Enter 4. Okay, let's check it again. Enter 4. So this is 2 4. Then suppose we want to insert at an internal position. Press 3. So enter the value of the node after which you want to insert a new node. So we want to insert after 2. Okay, now this option, enter the element you want to insert. Suppose we want to insert 5, right? Okay, let's check it again. Okay, this is 254. All are fine, right? So let's insert again an internal position. So now we want to insert a new node after 5. Okay, we want to insert 7. Okay, let's check it again. Okay, it is 2574. So all are fine, right? This was all for today. We will see deletion of single English in the next video. Till then, keep enjoying and thank you.